Okay, here we go with algebra. Notes 9, writing equations and inequalities. Make sure you put your name, date, and period in the blanks. Essential question is, how do you write equations and inequalities? And to do that, all you do is look at the words and the symbols and write it out as expressions. And equations have equals. Inequalities have greater than, less than, or not equal. So here we go with vocabulary. Open sentence is a mathematical statement that contains two expressions and symbols that compares them. Okay, an equation is an open sentence, but it's very important because it contains an equal sign. And the solution of the equation is a number that when you substitute it in for the variable of the equation, it comes out to be true. Oh, I skipped inequality. Inequality open sentence contains one of these three symbols or four symbols here. That is the less than or equal to, greater than or equal to on your paper. Okay, so the solution was a substitution of the variable. Inequality is a substitution for the variable in the inequality that still results in a true statement, but this one's a vast more examples that actually have. Okay, still using the words that we had yesterday to reference. So we're looking at this. It says the sum of 3 times a number a and 4 is 25. So the word is referencing my equals, and it equals 25. I can do that part real easy. The sum is a grouping word that is used to represent a group that is placed together. It's a grouping word, so I know that it's inserting in the and section of my sum. This is what I was referencing yesterday with the fact that and can be multiple representations. This has 3 times a number a, so that means that's going to be 3a, and is tied to the word sum, so it means I put a plus sign, the 4, and then I have the equals 25. Okay. On the next example in this area, it says the quotient. Okay, there's the quotient. I look for the and that tells me that's the grouping word for quotient. And it has the word it says a number x and 4, and then here's a very important word, is fewer than 10. Well, 10's my answer that I'm looking for. Fewer than, if I look up here, fewer than is the same thing as less than, which it means it's one of these two. And you got to know whether it has the equals or not. And fewer than means it's just the less than symbol. Okay? So if I look back at my original problem, it says quotient of x and 4. That means I'm going to have x divided by 4 is less than 10. Okay. On the next example, they say a number is greater than 6 and less than 12. So this is kind of a mixture of a problem. They're saying that this number is going to be greater than 6, and greater than, since the n is greater than 6 and less than 12, my n is in the middle. To be greater than 6 means I need the greater than symbol to point towards the 6. So n is larger than 6. But the n must also be less than 12. This is a little bit confusing, because if I first write this, I may want to actually write this in 2 different sentences so I can see it. Because it looks like n is greater than 6, and then n is less than 12. But when I put it into one sentence, notice the n is in this setup, is showing the same symbolization, other than the symbol is flipped. Realize the small end is still pointing towards the 6 in each one of them, and then this is just represented on this end. So this is a double compounded expression. Alright, the next set of examples, it says we want to check for possible solutions. So if I'm looking at my problem, this number on the end, they're saying that is what x equals. They're saying x equals 2. And we're going to check to see if it is true or not. So that means I'm going to plug it in. Remember, two numbers together means it's actually multiplying. So I'm going to do 7 times 2 minus 8. And then we're going to check to see if it equals 9. 7 times 2 is 14 minus 8. 14 minus 2 is 6. Does 6 equal 9? That is no, it's not a solution. If I look at the middle term here, they're telling me that y is equal to 6 by having that right there. It's separated by that semicolon. So if I replace it in my problem, that means I have 4 plus 2 times 6 is got to be less than 18. Well, 2 times 6 is 12, and 4 plus 12 is 16. Is 16 less than 18? Yes, it is. This is a true statement. Okay. And then on the last example here, it's saying, okay, well, the letter N, we're going to say it equals 2 because of that. If I replace it in my problem, that means I have 6 times 2 minus 9 has got to be greater than or equal to 2. 6 times 2 is 12 minus 9. 12 minus 9 is 3. Is 3 greater than or equal to 2? Yes, it is. This is a true statement. It is a solution. Okay. If I go to example 3, it wants us to use a little bit of mental math to solve these problems. And it says, okay, if we have x plus 6 equals 11, then what you should be thinking is, what number plus 6 should equal 11? Well, 6 minus 11 is 5, so it's like 5 plus 6 is 11. On the second one, we have 18 minus x equals 10. So what you're thinking is 18 minus what number equals 10? Well, 18 is exactly 8 above 10, so that means that this x must be 8. So if I check it, 18 minus 8 is 10, and that works. So to write my problem, n equals 5 and x equals 8. Okay, here are some independent practice problems I want you to work. The top ones, you write your equation or inequality. Both of these have an is, so that tells you these should be equations. These two, check your solutions to see if they are actual solutions or not. And the last two is your mental math problems. After you complete those, make sure you do your summary to answer your questions, and then I'll check your notes in class.